Swayam Prabha. Digital India. Educated India.
Hello and welcome to this first lecture on the course on Introduction to Computer and Network Performance Analysis using Queuing Systems. I am Professor Varsha Apte. I am faculty member in the Department of Computer Science and Engineering at IIT Bombay. So, at this point I would like to remind everybody to please have a pen and paper ready. There will be times in this lecture where I will ask you to just pause the video and write some thoughts for yourself. So, it will be useful to have a pen and paper. So, the name of the course is Computer Systems Network Performance. So, what exactly do we mean by that? Okay. I am sure everybody has seen this dreaded loading icon when you are trying to see some movie on Netflix or some even a lecture, let us say. Sometimes you will see this loading icon, and or if you visit a website you will see some icon which is showing you that the website is still loading. So, everybody who has done anything in computers and used networks have experienced this, and this is basically a delay in loading, right. And when you see this you might say that okay, today my network performance is poor, or today this application is performing poorly. But what exactly do we mean when we say performance? Okay. So, this is an excerpt from actually a dictionary meaning of performance. So, we all know that one meaning of performance is actually like an art performance of some kind, either a music performance or a dance performance or a performance of a play, and we might say oh that the performance of this actor in this play was really nice. Obviously that is not what we mean in this course. In this course the last definition on this slide is the one that we mean, which is the manner in which or the efficiency with which something reacts or fulfills its intended purpose. One way to use this word in a sentence in normal life would be the mechanic evaluated the car's performance in city conditions, right. So, you are talking about how well something does what it does. So, digging a little deeper into this meaning of the word performance. So, it is basically about how a system does its function, performs meaning does its function given that it is functioning. Okay. So, this is important when we talk about performance, let us say of a car. Okay. When we talk about performance we will refer to its characteristics like how many kilometers it is giving per liter, or how fast it can go from 0 to some 60 or 100, but we assume that the system is functioning. Sometimes in kind of loose language, and for the purpose of this course it will be wrong language, it can be the formal word for that is actually reliability or dependability. So, for example, in the car example, if we want to talk about how often the car breaks down, that would not be a performance matter, that would be a reliability matter. And just so that the difference is very clear in our minds, these two characteristics do not go together. For example, a car could be really efficient, or it could be very fast, it goes to 0 to 60 in a few seconds, but it could just fail all the time. Okay. Like okay, every 3 months it just breaks down, you have to take it to the mechanic for repair. On the other hand, a car could be very reliable, like it just goes off on for 5-6 months, like 5-6 years you have not had to do anything other than just regular service, it has never broken down, but it is just basically let us say a petrol guzzler. Okay. Maybe you just needs a lot of petrol, or it is basically just slow, does not really take a lot big go to very high speed. So, these are standalone characteristics, they do not go together, and so we will be focusing on this part, how well a system is doing its function given that it is functioning, that is the focus of this course. So, let us go further. Okay. Coming back to this dreaded loading icon, right. This icon is basically indication of a delay, right, something that you are waiting for. You wanted to start watching the lecture or the movie right now, but now you are delayed. The point though is that delays are not something that is specific to computer systems or network, right. We face delays in many places in life. So, maybe this is a point where on your paper that you have with you, you can write down places where you just have been delayed, you have had to wait for something. So, I will give you some examples here. These people are waiting for a train. This is some other country where people stand in queues like this, or maybe sometimes I have seen this at Delhi metro also, people stand in queues for the train. And they are going to face a delay. This person here is going to be have some time to go from here to here, and also they are just waiting for the train to come from whichever side. The train is not here yet. Okay. Then this is actually a photo of a poll booth, and these are all voters waiting to vote, and clearly this person here, this person here, and all of these people actually are going to face some delay. There will be some ID checking and so on that. So, they will spend some maybe hours in the line. Okay. Then we have this escalator here, right. This is people have come out of this train and there is a crowd here, and the people who were right here, they got onto the escalator quickly, but other people have to wait. Similarly, there is this woman, I mean there is nobody in front of her, but she is still waiting for the elevator because the elevator is somewhere else, right. Then we have this road, and we all know we have seen traffic jams in our life, we have spent a lot of hours in our life on the road. So, clearly whoever is here is going to be delayed to wherever they were planning to go, right. Just digging a little deeper into the delays, why do delays happen? I mean something is common between the 5 photos that I showed, right. The person waiting for the elevator, the road, the escalator, the poll booth, the train station. Is there something that is common here due to which people end up waiting? Okay. Think about it, write it down. Why do delays happen? One reason, of course, as we discussed during the definition of performance is breakdown, right. Maybe this person here has gone for a lunch break, or this escalator just was not working for some time. There could be breakdown, but the focus of this course, as I said, is not about breakdowns, and because breakdowns are not always the reason why delays happen. This person could be really working very efficiently, really trying to do the ID checks and everything, and very busy, not taking any breaks, but still a line can form, right. Similarly, this escalator could just be functioning perfectly, still there will be a crowd and there will be delays. So, it is not always breakdown is not the reason always. Okay. Actually, more commonly the reason is contention for shared resources. So, let me talk about each word. What is a resource here? The resource is the thing that everybody is using, and we can see here. So, for example, the road is the resource here, the poll worker is the resource here, the escalator is the resource here, and in the previous photos it was the elevator, somewhere it was the train, right. These are all the common resources and they are shared. Obviously, the road is not only for one car. So, if you are living in a bungalow and there is a driveway that just comes to your bungalow, then sure, that road is not shared by anybody, and of course there will never be any delay to get onto that road. If the elevator was like maybe you own the building and the elevator is just for you, the elevator could always be parked wherever you just got off. So, you are going to go there itself and there will never be any delay. But normally that is not the case. Resources that we see that where delays are happening, those are happening because they are shared, and there is contention, meaning people are competing for the resource, they are all vying for the same resource, they all want the same resource, they also want their desire to use the resource comes at the same time. If it also came very regularly at different times, then also there will not be any problem, but that contention, meaning it is a competition and it is a desire to use the same resource at the same time. That is the root cause of delays. Okay. So, sharing results in building of what we in general also call queues, and in computer and networks also we will see queues. Sometimes of course they are just like crowds, but in some abstract sense there is a queue, there is no order, but there is a queue for the shared resource, and queuing is what results in delays. Okay. So, what do delays depend on? Okay. Let us keep further thinking in general life. Okay. So, here for example, what are all the factors that will determine how much delay this person for example will face? So, there are many things one can think of, but the main common ones I will list. Obviously, one thing that will come to our mind is the speed, right. So, how long does the poll worker take to check the ID or whatever of one person, right. If it is 1 minute per person, the delay from here to here for this person will be less. If it is 5 minutes per person, it will be more, simple as that, right. So, how speed is of course a rate. So, you know, can the poll worker check 60 IDs per hour versus only 10 IDs per hour. So, that is the speed. Okay. Then number of resources, you can see here there seem to be 3 lines 1, 2 and 3, that means there are 3 desks where people are checking the IDs. If there was one more here, one more here, then clearly there will be less delay. Okay, so, the number of resources matters. Similarly, here you can think that if there was one more escalator on which people could go up, there could be less delay. Then the next one is workload intensity. What do I mean by workload here? It is basically the amount of work, it is the same meaning that we have in normal life. What is the workload that is coming to this poll worker? Meaning you can say how many people per hour are coming to this polling station. Okay. Clearly if everything is the same, there are 1, 2, 3 desks and the speed of the poll worker to check the IDs is the same. Even when all of these are the same, the rate of people coming to the polling station per hour will impact the delays. So, if there are, let us say 200 people coming per hour versus 500 people coming per hour, so 200 arrivals per hour versus 500 arrivals per hour, the delay will be different because the lines will get longer, right. For 500 the line will be longer, for 200 the line will be shorter, even if rest 3 are the same. So, one is that is the intensity, this is some sort of a rate of work coming to the resource, this it will depend on this. It also depends on the nature of the workload. Okay. So, just you give your attention to this example here. Here consider 2 conditions. Okay. One where if persons arriving per minute to this escalator versus 100 persons per 10 minutes. Okay. So, 10 persons per minute and 100 persons per 10 minutes, this is actually the same rate, but the nature of arrivals is different, right. So, if the train here is coming every 10 minutes, okay, the train here this is a realistic example, maybe the train arrives every 10 minutes, and when the train arrives 100 people get out of this, right, 100 people come out of this and then they queue for this escalator. If that is the case, then the crowd will form, but if you can think of 10 persons per minute coming here, 10% does not look like there will be much delay, they will be able to go up this escalator pretty fast versus 100 persons every 10 minutes. So, in this case the rate or the workload intensity is actually the same, but the nature is different. Okay. And this kind of second thing is called bursty, means there is a sudden burst of work. So, if there is a sudden, even in this case for example, if whole morning nobody came and 11 AM suddenly like 1000 people landed up here, right, like, okay, then the line will be very long, right. So, the nature of workload is important as and not only the overall rate. Lastly, the resource sharing policy or what we call scheduling policy in computers and networks, that can also make a big difference. What do I mean by that? Consider these 2 examples. Okay. Here this is a resource, it is being shared anytime there is a resource and it needs to be shared, you should have a rule about sharing it, right. The policy means some kind of a rule. So, first come first serve is one kind of a rule. It is also called a scheduling policy. So, here obviously it seems like it is first come first serve. Here there seems to be no policy, right, no rule. People are just going, whoever can push ahead is pushing ahead. So, clearly there will be some difference in the delays here. Here it will be a little more predictable, here it will be a bit unpredictable. So, now also compare these two roads, right. Here there seems to be a very clear sort of lanes and they are all standing behind each other. So, we expect that the time for the car to go from here to here will be different, probably shorter than whatever is happening here, where there seems to be the road is shared by moving cars, by parked cars, by people. There does not seem to be a clear rule on where should people be, where should parked car be, where should moving cars be. So, we expect maybe more delays there, right. So, the sharing policy is very important, resource sharing policy, and that will also affect delays. Now, why did I talk about all of this, right? This course is not about roads and escalators and elevators and all that. The reason we talked about this, of course, is that the root cause of delays in computing systems and networks is the same. It is the fact that there are shared resources, and because there are shared resources, there are queues. Okay, so again in your notebook, think of some resources. Here is where it is useful to recall the prerequisites for this course, you know, the OS, networks, all kinds of undergraduate prerequisites. So, think of hardware, computer hardware also. There are many resources, okay. The most simple resource that comes to mind is CPU, okay. And when you think of any resource, think of who uses it, okay. A CPU is used by whom? If you remember your operating systems, the entity that is actually scheduled on the CPU, it is called either a process or a thread, right. Or you can think of a network link, right, a network link. What is it that actually goes on a network link in terms of computer networks? I mean, you can think of many things, it is you know, electromagnetic signals and so on, but a computer networking view of link should suggest to you that the thing that uses links are packets. So, in this way we can think of resources and users, and these are shared. A CPU is never in a modern CPU is never only running one process or one thread. It is running actually hundreds of processes and hundreds of threads, and there can be only one CPU and hundreds of threads, and they have to wait their turn to run on the CPU. So, there are delays. Packet, lots of packets go on the link, and if many thousands of packets come to one link at the same time, like happens when you are downloading a file or something, then there will be a queue. Okay. So, here are a little more detail of that example. Look at the first example of a packet queue for network links. This is basically a network here, these are switches, and there are links shown, and this is here an IP camera that is connected to this switch. Let us imagine that there is one more switch here, okay, one more camera here. Let us say there is one more camera also sending. So, this IP camera will be sending packets here, this IP camera will be sending packets here, and let us imagine that all of this is going to this router here. So, if all of these packets are going on this shared link, this is basically shared, then a queue will form, right. On this outgoing link there will be a queue. Okay. Similarly, you can consider this computer and this laptop. Suppose they are both talking to this laptop, they are both, suppose this laptop is downloading a file from both these computers at the same time. So, again this computer will send packets here, this laptop will send packets here, and both these will be queued, will be wanting to be sent on this link. So, a queue will form here. Okay. Similarly, there are when we go to a website, we send an HTTP request. If you remember, again remember your application layer protocols, what goes to a website is HTTP requests or web requests, right. It is a web request going to a web server. A web server is nothing but a process with multiple threads running on a server machine, right. So, here I have shown 4 lines to represent 4 threads. So, suppose these are all busy right now working on some request, then the next request that comes here will have to queue, and this will basically be a buffer some in the computer memory. These requests will have to be just placed somewhere in the computer memory, and this will result in delays. Similarly, the CPU itself, like I said in the previous slide, the CPU itself is a shared resource, and in fact these threads are software entities, they have to run on a CPU, right. So, these threads will be the ones actually contending, right, contending for the CPU. So, this can be thread 1, thread 2, thread 3, thread 4. So, if we again think about the resource and the queues that form in front of that, this is what leads to delays. Okay. When you click on your YouTube link sometime and you see this loading icon, somewhere here, in fact this shows the whole journey, that the packets would be queuing somewhere in some switches. First your request will queue for the threads might be queuing for the CPU, then even if the machine starts sending packets, the packets might queue on so many routers all across the world until they come to your laptop or your mobile phone. So, it can lead in, sometimes it is fast, sometimes everything is nice, so there are not many queues, but sometimes there will be delays and they will be very perceptible to us. Okay. So, this is just putting down the pictures in the previous page as a list with some more examples. We already saw the CPU and the thread as a resource, we saw the web servers threads and the HTTP requests. Here in fact there is an interesting thing here, that in this example the threads are a customer or a user. Customer is a word we often use to describe these users and the things that queue for resources. In a very general terminology, if we want to use, we sometimes use the term customer. Okay. But you can say the thread or the process is a user of the CPU, but it also is a resource itself, okay, for which HTTP requests or web requests queue. So, a resource can sometimes be a customer of another resource or a user of another resource. Okay. We saw this link example with IP packets as the users. Similarly, we can have a wireless medium. Many of you who are watching this lecture might be on a wireless medium, and currently your laptop will be downloading these packets. The packets will be coming from a Wi-Fi router to your laptop, and so the wireless medium is a resource. It is being shared by possibly your laptop and many other laptops which are on the same Wi-Fi network. If there is nobody on the Wi-Fi network, then you are then your YouTube video is the only one using the network, but if many people are using the same Wi-Fi, then it is a shared resource. Okay. So, the users are frames, at the link layer packets are called frames, right. So, we call them frames here. Printers are often shared, and then the print job is the user. This is another interesting example where we have web server threads again become customers for a log file. Many times server processes write something to a log file, like what time did the request come, how long did it take, what type of request it was. So, when it does that, all the threads have to use a common log file. Then this log file is a resource, because if another thread is writing to that log file, the other thread who also wants to write to that log file has to wait. So, there is actually a queue of threads waiting to write to the log file. Okay. Another very important example is cellular network channels. So, when we use our mobile phones and make a normal cellular call on our mobile phones, they actually go on these things called channels which are owned by the cellular operator, and the user entity there is the call itself. The channel has to be given to the entire call. And sometimes if there is a lot of traffic, nowadays it does not happen much, but if there are not many channels and there are too many users, some emergency has happened, everybody is trying to make a call, you will get a network busy signal, right. You will get on your phone actually a message which says network busy, that means all the channels are busy. Okay. So, these are all the resource and user pairs, and it is useful to think in terms of these pairs. Clearly there is a notion of performance right, that exists for all of these resource user pairs, right. There are the notion of performance is often seen as delays. We often say something is slow or something is fast. That is one very common way that we describe and we talk about performance of a computer or network system. But can we formalize it a little more? Can we talk about a few performance metrics like the time to load a web page, that is a metric. Similarly, all of these, just as we discussed, the delays depend on number of shared resources, the speed of the resource, the workload intensity. Can we, for each of these systems actually, the ones that we listed here, can we be more specific? The earlier discussion was in the context of roads and escalator and elevator and poll workers and things like that. Can we talk in terms of computer systems and networks and identify some parameters on which these are the factors on which the performance will depend on. Okay. So, this is what we will do in our next lecture, and thank you for listening.